All right, here we go. So, put it to use. This is an inverse sine function. The input is either a y coordinate or an opposite over hypotenuse ratio. So we have to identify, first of all, is this a y coordinate on the unit circle that we've seen before? Mm-hmm. Yes, many times. Okay, so since we recognize this as a y coordinate that we are familiar with, we'll use that interpretation of arcsine as the pi value with, so this is where we say the pi value, I'll even color code this for you guys, with a y value of radical 2 over 2. Okay? Now we have to be careful. Remember, okay, asterisk, the range is from negative pi over 2 to pi over 2. So we can only accept an angle that's between negative pi over 2 and pi over 2. So not only a pi value with a pi value with a y value of this, but also it has to fall within this range, right? So what do we have? Pi over 4. Okay, pi over 4 is our answer. Let's jump down here to the next one. Pi value with a y value of 2.
No.
No. Is there an angle that has a ratio of an opposite side over the hypotenuse of 2? Because that's our other option, right? 2 is not a y value on the unit circle for us. So if we can't use that, maybe we can use the right triangle trig, but that would mean that there is some angle in a right triangle that has a sine ratio of 2 over 1. It has an opposite over hypotenuse value of 2 over 1. I'm getting some head shakes. Why not? Because the hypotenuse has to be the longest side in a right triangle, right? Mm-hmm. Now go back to the beginning. What is the domain of an inverse sine function? From negative 1 to 1, right? So, does not exist. You could say empty set. You could say does not exist. You could say undefined. Whatever you want. The bottom line is 2 does not fall within the domain of arcsine. Look at this one. Let's go through this one together. So we have the cosine. This is what we call a composition, right? When you look at this, there's two functions here. We have the cosine function in the exterior. In here, we're taking the inverse sine of negative 1/2. So again, the inverse sine. Now, let's do this without the calculator. When we execute this function, we're trying to find a pi value with a y value of negative 1/2. Is negative 1/2 a y value that we see on the unit circle? Mm-hmm. It should be. I hope it is. Crossing the fingers again. I sure hope so, because we've done enough with it at this point. So we're looking for, maybe if we want to write it like this, if you're more comfortable with this concept, a pi value with a y value of negative 1/2 from negative pi over 2 to pi over 2. That angle,
negative pi over 6.
Negative pi over 6. So the output of this function, the value of the arcsine of negative 1/2, the output is the angle negative pi over 6. Now what are we doing? Now we're taking the cosine of that, right? This is how we slide into talking about inverse cosine, by doing this composition. This is called scaffolding. It's a master teaching technique. Okay, just so you know. Just so you know. That's why I'm recording this. Like I said, I'm going to send this to the Smithsonian. Okay? So we have the cosine of negative pi over 6. We take cosines of angles, right? And when you want to evaluate the cosine of an angle, you look at the x-coordinate of the angle, right? So this is an angle. The output for a cosine function is the x-coordinate at negative pi over 6, which is radical 3 over 2.